See for me if you could graph those two equations. There's two examples up there. See if you can just kind of review what we've been working on. Graph those two equations in the same coordinate plane. I'm going to do it up here on my paper quietly so I don't interrupt you. Just as a little tiny review. Remember, you only need 2 points to make a line, play connect the dots. What can you guys tell me about that first picture that you graphed? What can you tell me about these two lines? Yeah. How do you know? Exactly. These guys are parallel. You could actually, if you wanted to, without you can probably see from the graph, but without graphing, you can actually just see that they have the same slope. Just to remind you of that. Bless you. And the two lines next to this, right, they're intersecting. Are those two lines perpendicular? Because they have opposite slopes, right? What would I need to be perpendicular here? They have opposite slopes. Is that okay? Is that enough to be perpendicular? You can probably tell they don't make right angles, right? What do I need to be perpendicular? Flip the numbers. So these do intersect, right? They share a point here in common, which you're going to see on almost all the graphs, or all the graphs we're going to do today. But they are not perpendicular to each other because they're opposites, but they're not opposite reciprocals for the slope. Anybody have a question about graphing those? Okay, now I don't know if you guys will have ever graphed what we're going to do today because they stop doing absolute value stuff in Algebra 1, so you may not have seen this before, but we've been working with a couple lessons ago, absolute value equations and inequalities. We're going to graph some today. Before we do that, though, I got to have you know the domain and range for these graphs, so we're going to talk about that real quick. What do you think of when you see the word, like, domain of a graph? Like, what does the domain represent? X or Y? Thank you. Okay. Heart palpitations. Okay. Domain is all your possible X values. Now, this will make more sense when we start doing this in a second. Whenever you describe the domain of a graph, though, you are describing what is the graph doing from left to right. And we're going to describe these in that interval notation that we started using a few lessons ago. So I'm going to work through that with you guys today. But domain is all your possible X values, and it's how the graph moves from left to right. All right, so spoiler alert, that means the range is all the Y values, right? Because we only got 2 values on our graph. So the range is all your possible Y values. And when you do the range of the graph, I always tell people you're going to go from the bottom to the top. when you do your description. How is the graph moving up and down? But you start at the bottom of the graph and tell me the lowest possible thing y could be, and you move to the top and tell me what the biggest possible y could be. When you do the x values, you start all the way to the left. What is the smallest x value? You go to the right. What's the biggest x value? All right, now, these first two, these are the only two I'm going to have you guys do with the table. But I'm actually going to plug an x. I just made a little table for you. We're going to plug values in for x. This is y equals absolute value of x. So whatever we plug in for x, that's our independent variable. And y depends on what we plug in for x. So if I plug in -2 and I do absolute value of x, what would I get? If I plug in -2? 2. All right, what if I plug in -1? 1. All right, 0 would stay 0. Now, what would I get if I plugged in 1? It stays 1. Sometimes people trip up and they'll start to, plug in a positive number and make it negative because they get confused. But this should make everything positive here. And so again, if I plug in 2, I would get 2. So let's just come over here and plot these lovely points. And hopefully you guys will see the shape that this makes. Right. Absolute value makes everything positive, right? So I'm not going to have anything down here. Basically, don't draw this on your graph. I'm going to show you this. If we just graphed y equals x, it would be a diagonal line that would go right through there. What the absolute value does is takes this part of the line and flips it up. Anytime you have an absolute value, I like to write this on here, absolute value, it makes a V shape. All right, so that is just your basic absolute value graph, makes a V shape. The vertex is going to be right in the center, and that is 0, 0 on this graph. We're going to shift these around a little bit today, so I'm going to show you how to do that. But basically, look at the function real quick here. Out in front of the absolute value is just a 1. And so what I think of there, and I put it in quotation marks, is like the slope of the two sides of this, which would just be 1 over 1. So if you can find the middle, you're just going up 1 over 1, up 1 over 1. On the other side, same thing. That's why I put this in quotation marks, but this is going up 1 over 1 to the left, which would technically be -1. But if you can find the middle, just use that slope and go like this one, up 1 over 1 on either side, and that'll create your V shape. Does anybody know if I mix up the absolute value and put a negative in front of that, how would that affect the graph? Like, how would it be different from the one we just did? I love your hand motion. He just said it's just going to flip it over. So basically what this says here, you have a -1 in front of this, right? So when I plug in the x value, the absolute value is going to make it positive, and then every single one of those values would get multiplied by -1. So that's just going to flip the graph over. 0 will stay 0. But here you're going to take the absolute value, which would make everything positive, and then I have a little -1 in front of that, which makes everybody negative, and it's just going to take your V shape and flip it upside down. Now, 0, 0 is still going to be the vertex of this guy. We're just going to point down, and what I would tell you here for your slope is what I'm doing there, I'm going down 1 over 1 on either side of that vertex. Just down 1 over 1, down 1 over 1 to create that V shape. Okay, now let me back up. Let's talk about the domain and range. So, domain, think about like going all the way to the left forever to -infinity, all the way to the right forever would be going to +infinity. So if I'm going from left to right, look at how the graph goes. What would the smallest possible x value be? Anybody know? The way that arrow's pointed? What do you think, Liam? Okay, like just pretend my graph was bigger. Like if it just kept going. Exactly. This would go to the left, right? It's going up, but it's also going to the left forever. So for my little infinity, I'm going to do an interval. It goes all the way left forever, -infinity. What does it do as I'm going to the right? What x value am I going to as I go to the right? You guys see, this is pointed up, but it's also pointed over to the right. So both sides here, you go from -infinity to infinity. You would literally cover every x value on that graph. If we had a bigger picture of that, it would go on forever. Okay, now here's the deal. For the range, come from the bottom to the top. I'm not touching any part of that graph, right? What is the first y value I touch? Perfect. Okay, so you're just grabbing the y-coordinate of that point. Now, do I actually touch the point, right? It's a point on the graph. So I'm going to use a bracket here, and it should be 0. All right, now, pretend I had a giant window for this. Both of these ends of this arrow, one's pointing left, one's pointing right, but they are both pointing up. So I would keep going up forever. What would my biggest y value be then? Yeah, exactly. So it just goes up forever, up to infinity. Okay, now, this is a little trickier. I got my graph flipped over, right? What would you tell me? Think about going from left to right. What is the smallest x value if I continued this graph forever? What is the smallest x value I would go to? Like all the way to the left, what would you think? If I'm looking at that, like if I kept going forever, all the way to the left, where would your x values go to? What do you think? Oh, I thought you were raising your hand. What do you think? Yes, it throws people up. This is going down, right? But it is also going to the left. Like I would keep going over here forever. You would keep covering all your x values. Negative infinity. All right, now, same argument on this side, right? This, I'm going down, but I'm also at the same time going to the right. So that would also go to infinity, even though it's pointed down. Right, you're going to notice for every single absolute value graph we're going to do today, they all, even if we shift them around, they all have the same domain. One side will go left forever, one side will go to the right forever. It doesn't matter if it's pointed up or down. That's going to affect the range, not the domain. So all the domains for all these graphs today will be the same. Okay, now for your range, what is your lowest? Think about going from the bottom. What is the lowest possible y value for this absolute value with the negative in front of it? Lowest possible value. What do you think? Yes, this is pointed down forever. So infinity symbols are always going to have a parenthesis, don't use a bracket. Okay, now, if I'm coming from the bottom to the top, like I would be touching part of this graph, what y value do I stop touching the graph at? 0. Exactly. You actually have a point there, so then you're going to have a little bracket. So all the domains will be the same today. The ranges, just in general, I'm going to write this just like really briefly under it. It's the y-coordinate of the vertex and then infinity. Just in general, if the graph is pointed up. If the graph is pointed down, it'll be negative infinity, and then it'll be stopped at the y-coordinate of the vertex. Just in general. And then that will always have a bracket. So the y-coordinate of the vertex is really the only thing you have to pick out for these graphs to do the range. Domain should be the same for every single one. Now, we're going to shift these graphs around a little bit. So I'm going to give you two. And the first one's just a vertical translation. So let me give you a basic example. So vertical translation, I'm going to have y equals absolute value of x. And then you'll see these letters all throughout the semester. They use them for all different shifting of quadratics, radical, everything we use it for. For today, absolute value. I'm going to put plus k, letter k, outside the lovely absolute value. Now, if you have a vertical translation, we're going to either go up or down. It's going to shift the graph. The y-coordinate of the vertex is basically what that is. Now, we're going to go up or down, and I'm going to write the way you think. All right, so if it's like plus 5, we're just going to shift everybody up 5 spots. If it's minus 6, we're going to shift everybody down 6 units. That's all it is. So, to find your vertex, if you just have a plain x inside the absolute value, the vertex is based on whatever's inside with the x and whatever is outside. Whatever's inside with the x, which is nothing here, is going to be the x-coordinate of your vertex. Whatever is outside, you're just going to copy that number. So I'm not moving left or right here because I just have x inside my absolute value. I'm going to go down 4 is what that negative 4 is going to do. So I'm just going to do minus 4. And then all you're going to do, we're just going to come over to the graph. So instead of starting at 0, 0, we're going to start at 0, negative 4. Okay, if you want to make a table, you can make a table. I would not do that because I'm going to show you a way that's much easier. What would you tell me the slope for that equation would be? Like, what's in front of your absolute value? 1. Okay, and I'm putting it in quotation marks because technically one side is 1 and one side is -1, but I'm just going to go from that vertex, just go up 1 over 1 on either side. This will create the V shape. Just up 1 over 1 on either side. We're going to play connect the dots, make your V shape. That's all you have to do. All right, now for my domain, remember I promised you, one side of that graph, left forever, one side right forever, so -infinity to infinity. The range is the thing that will be different for each graph depending on the equation. So this is pointed up, come from the bottom of the graph. What is the first y value you touch? If I'm sliding my pen, I'm not touching any part of the graph till I get to that vertex. What's the y coordinate of that vertex? What do you think? -4. All right, you actually touched the point, so we're going to use a bracket. So -4, and the rest of that V shape just goes up, 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 up forever. So the biggest possible y value there is going to be infinity. All right, does anybody know what I would have? My next example, I've got y equals negative absolute value of x plus 5. Is that going to go V shape right side up or upside down? Up or down? What do you think? Oh my goodness, go ahead. Liam, what do you think? Down. All right, you guys can talk. It's okay. So, little negative, just go flip it down. All right, can anybody tell me what the middle or the vertex of the V shape would be just looking at that equation? What do you think? The vertex, like both point, like the x and the y.
Oh.
Yes, okay. So, nothing inside with the x, so the x coordinate of the vertex will be 0. That plus 5 is going to take this graph and shift it up 5 units. If you guys want to look back, basically it's this graph we just did, but we're going to scooch everybody up 5 spots. So you're going to start at 0, 5. All right, now, just like I was telling you with the last one, the slope here is just -1. So once you find that vertex, just go down 1 over 1 on either side of the vertex. And you don't need a ton of points here. I just graphed about 5. The vertex and 2 on each side. That should be my shape. Now, no matter what, even though this is flipped over, this one side of this arrow is still going left forever, this guy's going right forever. So -infinity to infinity. Now, I always think these are tricky for people, especially when you're getting used to the interval notation. So the range on this, you guys start with the lowest value. This is pointed down forever. So this would go all the way down for your y values to -infinity. And if you were tracing this graph like your pen or pencil, go from the bottom to the top, you stop touching the graph when you get to that vertex at the top, then there's no more graph up here. So it's the last y value you touch, which you should be able to just grab from your equation or look at your picture here. That last y value is 5, and that would have a bracket on it. Is anybody having a question? Okay, now the other one, this is weirder. So a horizontal translation, I'm going to go back kind of up here, write this for you. So horizontal translation, you're going to have some number inside the absolute value with the x. All right, and we use h to represent that. So that's going to end up being the x coordinate of your vertex. So I'm going to show you this real quick. This is going to shift your graph left or right. And this is always tricky, and I promise you, we will literally use this all year because it's the way you shift different graphs. This is the opposite way you think. When you're looking at an absolute value, a square root, a quadratic, they all have these same properties. We're going to do all kinds of stuff with these graphs this year. But inside the operation here is absolute value with the x. It moves the opposite direction of what that looks like. So, like if I look at my example here, I've got y equals absolute value of x minus 3. I think that looks like a -3, so I would move that 3 to the left if I didn't know better. What it is, the reason it's the opposite way you think, if I were to plug in +3 here, that would set that middle part equal to 0, where it sets it equal to 0, that switches from one side of the v to the other. So to me, that looks like I look at that and I go -3. It is the opposite of what you think. So if I see x minus 3, I write down a +3. It's actually what sets the inside equal to 0. That flips it from one side of the v to the other, so that gives you the x coordinate of the vertex. Now, in this particular example, I don't have anything added or subtracted, right? There's nothing to the side of that absolute value, so you're not moving up or down. So the y coordinate of the vertex would just be 0. So when you plot this, I'm just going to find -3, 0. Just has a little 1 out in front, just plain absolute value of x. So we're just going to go up 1 over 1 on either side of that to make our v shape. Once you find that vertex, if it's positive, you just go up 1 over 1. If it's negative, you just go down 1 over 1 on either side of that vertex. Now, I promise you, all these domains are the same. So -infinity to infinity. I can write that on the next question without even doing it. The range is what you got to be careful with. Now, I find this will be very tricky for people, especially if the vertex is on the x-axis somewhere. So, if I come from the bottom to the top to do my range, what is the first y value you touch? Don't say 3. What's the first y value I touch? 0. I don't know why, but it always trips people up when it's on the axis. Yeah. Fail. Fired. I didn't graph that. Okay. It should be over here. Sorry. Okay, hopefully you guys did pencil. That's not going to affect my domain or my range or my domain though. I graphed it on the wrong side. My apologies. Now, 0 is still going to be the first y value you touch. I don't know why, but for some reason, if it's on the x-axis, that'll throw people off. But you want the y coordinate, then both sides of that v go up forever. Now, the one next to this, again, whatever's inside with the x, it's the opposite of what you think. So to me, that looks like a +2, so I automatically write -2. If I plugged in -2 inside that absolute value, it would set that equal to 0. That's where it switches from one side of the v to the other, but that's why it's the opposite of what it looks like. And then nothing added or subtracted to the side, so 0. This guy has a little negative in front. So I know that's just going to turn my V shape upside down. So don't do like I did on that last question. Make sure you go to the right point. So this one is -2, 0. And then just go down 1 over 1 on either side of that. And just going to connect it up. It's like 2 rays that intersect at that vertex. This one's a little trickier. The lowest y value, this pointed down, -infinity. And then you would stop touching the graph when you get to the vertex. The y coordinate again there. Just be careful. Sometimes when it's on the x-axis, people get tripped up, but the y coordinate should be 0. That's the biggest y value. You don't have any y values above that. Is anybody having a question? Okay. Now, diagonal translation is basically just like left or right and up or down within the same problem. All right, so I'm going to write this for you. Just at the top, let me see if I can squeeze this in. So if I put those together, the two that I was talking to you about on the other side, the general form for that is y equals x minus h plus k. All right, now, I always say this. You'll hear me say this 1,000 times to you this year. The vertex is hk from that lovely formula. That's the vertex. And I'm going to say this, I'm going to put it in a different color here. I always tell people opposite copy. Because where the x, inside with the x, that's going to be the x coordinate of your vertex, but it's going to be the opposite of what it looks like. Outside the operation here, it's an absolute value. You just copy that number, and that is the y coordinate of your vertex. And if you guys see this, I just kind of mix these into a couple. F of x is just function notation. That is the same thing as y equals. So if you see that on anything, that's just what it means. It's just a different type of notation. So if I'm looking at my lovely absolute value, right? If I want to find my vertex, opposite copy, I look at that and I go, okay, -2, bless you, -5. That's your vertex. So I'm just going to find that point on my lovely graph, -2, -5. And then for my slope, if you will, you don't have anything out in front of this absolute values. So just want to think of the slope of the two sides of that as being 1. So just from that point, just go up 1 over 1 on either side. That'll give you your V shape. When you look at the domain, doesn't even matter if it's an absolute value graph, it'll automatically, one side of that V will point to the left forever, one side will point to the right forever. You'd cover the entire x-axis. The range is what you got to kind of think about for a second. If I'm coming from the bottom of the top trying to trace this graph, what's the first y value you touch? What do you think? Negative, what'd you say? I think did I do it wrong? We're scooched down just a little bit more. Maybe negative 5? Negative 5 on that one? Goes down just a little bit farther. The intercept is negative 3. The y-intercept is definitely negative 3, but the graph goes down just a teeny tiny bit further, and then everything else goes up forever. So you're going to go negative 5 to infinity. The y-intercept is definitely negative 3. You want to go with the vertex when you look at that. All right, see if anybody on the next one. I got y equals negative out in front, so I immediately know this should turn upside down. Absolute value, x minus 4, and then I have plus 3. Anybody feel like they could tell me where the middle of that, where would the vertex of that be? What would the vertex of that absolute value be? What do you think? Perfect. 4, comma 3. Opposite with inside with the x, opposite of what it looks like, copy what's outside with the y. So we're just going to go 4 over 4 up 3. And again, I've got the, if you will, the slope. I'm going to go down 1 over 1 on either side of that to create the V shape. Just down 1 over 1, down 1 over 1. All right, now domain, doesn't matter. It's the same for every one of these absolute value graphs. Doesn't matter if it points up or down. The one you got to think about is the range. All right, so I would point down forever. So the lowest y value, negative infinity, and then I stop touching the graph at what point? What y value? You guys are so quiet. What's the y value? What do you think? 3. Okay. Use a little bracket because you actually touched the point. All right, is anybody having a question? All right, now we've already talked about and seen a couple of these. I just want to give you a formal, what is this called? So what they call a reflection, what basically if I flip my absolute value down, that's just going to have some kind of negative in front of your absolute value. So that's called a reflection. Maybe I'll jot this down. It says, they call it a reflection over the x-axis. But if you see a little negative out in front of your absolute value, just flips your V shape to go upside down. All right, horizontal vertical translation, this is what they call a diagonal translation. Also, this is your HK, is your vertex. So we've already done that too, just to put it all in one place. And then what we're going to end with today is some graphs that have a little bit different, what I would call a slope, like in quotation marks. So that is going to be affected if you have a number out in front of the absolute value that's not just a negative symbol or not just a plain absolute value. So we'll call this C. And this is what we call a stretch or a shrink. All right, so in this case, we're going to ignore any negative. If it has a negative, that's that reflection transformation at the top. Okay, so if it's negative, it just tells you whether it flips right side up or upside down. So ignore the negative, whatever number's out there. If that C value is greater than 1, okay, so ignore a negative. If it's bigger than 1, so like if I have a 2 out in front or something like that, this is called a stretch. And basically any kind of a stretch is going to make the V shape more narrow than what we've been graphing so far. So if it's equal to 1, it'll just be like the ones that we've graphed. If it's greater than 1, it's going to cause a stretch. All right, and second one, ignore the negative. If that C value is between 0 and 1, so not equal to 0, because then it wouldn't exist, and not equal to 1, that would be something like we'd have a 1/2 or a 2/3 or something like that. That's what we call a shrink. And a shrink basically compresses the graph and would make the V shape really wide compared to what we've been graphing. And what I did on each of these graphs is I just put like the basic y equals absolute value of x so you could kind of compare when we look at it. What you do to find the vertex is exactly what we just did, just opposite copy. This is just going to have a number in front of the absolute value, and I'm going to show you how to deal with that in a second. So we're going to try to graph y equals 2 times absolute value, x minus 4, and then plus 1 on the graph with this absolute value of x already there. Can anybody raise your hand and tell me the vertex? No, he's not in this. Don't worry. Sorry about that. Can anybody tell me the vertex of this graph? What would the middle be? Just do the opposite copy. It doesn't work any. It doesn't. The 2 doesn't matter. Opposite copy. What do you think would be in the very middle? Go ahead. Perfect. Positive 4, positive 1. Okay, so find that point. Well, kind of like right in there. Now, the only thing the 2 is going to do is affect what I was calling your slope. And again, I'm putting it in quotation marks because technically one side has a positive 2 as a slope, the other side's technically negative 2. But if you just think about it like this, it'll be easy to do. So I'm going to put that over 1 to make sure I don't forget. So I got a 2, that number out in front. All you're going to do on either side of that vertex, just go up 2 over 1. Up 2 over 1. And you'll see this is much more narrow than the graph is that we've got going on here. So what this is doing, this is shifting our graph. Okay, so I'm going 4 units right. I'm going 1 unit up. And this would be a stretch of 2. And that's all the transformations that's going on in the graph. So my original started at 0, 0. We're going over 4 to the right, up 1. And then I'm making my slope more stretched out by doing 2 over 1, and they call that a stretch. That's all you have to do. Okay, see if you guys can try this one. Same thing, I've got y equals absolute value of x just so we can compare. So this says negative 1/2, and then in your absolute value, x plus 3 plus 10. Can anybody just raise your hand and tell me what the vertex of that would be? We'll be in the very middle of the V. What do you think?
Negative 310.
Perfect. Opposite copy, negative 310. So find that point. We're going to go 3 to the left, up 10. All right, now, 2 things here. What I'm going to say as my slope, again in quotation marks, you have negative 1/2. So the negative is going to flip the graph to go upside down, and I just graph it using that negative. So negative 1/2. Just from your vertex, all you're going to do on either side, go down 1, but go over 2 on either side. So this will be wider than the graphs we've been doing. And you can repeat that. Just go down 1 over 2. All right. Much wider. Now, if I were going to describe this transformation, this one kind of has 4 different things. So technically, because it's flipped over, it's got a reflection over the x-axis. We're going left 3. We're going up 10. And then this one, because it's wider, is called a shrink of 1/2. The negative just tells you whether it turns right side up or upside down. And in terms of the shrink, if you wanted to put negative 1/2, I wouldn't count points off or anything like that, but that's what causes it to go the upside down. Does anybody have a question? Okay. Let me see if you guys could write me the equation for these. First thing you'd want to do, find the vertex. So I'm just going to jot that down. Looks like the first one is 1, negative 4. The second one looks like negative 3, 2. And the third one, 0, 5. So that's definitely part of the equation. Now, the other thing I would need would be the slope, if you will, of the sides. This one, you're just going up 1 over 1, up 1 over 1. So I'm just going to say the slope here would be 1. This one, you're going down 1 over 1, down 1 over 1. So I'm going to say here the slope would be -1. And, ooh, the last one, let's see. I'm just trying to look through a point that goes right through a corner. This looks like it's going down 2 over 3. So I'm going to say the slope on this last one is -2/3. So we're going to see if we can write the equation. Let me just give you the little format here. So C and then x minus h plus k. The hk is the vertex, and then the c would be your slope. All right? See if you can set up an equation, plug in the numbers from the problem. I'll just come around and look. You see if you can try that on your paper real quick. See if you can set up the equation. And if you're feeling really good about this, feel free. If you want to start working on the homework, it's in the homework packet you're going to draft by the end. And actually draft it. Yeah. All right, anybody feeling good about the first one? What'd you write as your equation? Y equals what? Go ahead. Perfect, perfect. If the slope is just 1, you don't have to put, if you want to put a 1 out in front of that absolute value, you can, but you don't have to. Is anybody feeling good about the second graph? Liam, what do you think? Mm-hmm. Perfect. Awesome. Okay, anybody have a question about that? So whatever the x is, it looks like the opposite, because the way the formula is set up, it's x minus the x coordinate. So like if I were to actually just plug in 3 to that general form, you'd have minus the -3. That's why it looks like the opposite of what it is. That's why I keep saying that to you guys. Anybody want to try the last graph? What'd you put? Yes, just there. It doesn't shift left or right, so just an x by itself in the middle, and then plus 5 on the outside. Is anybody have a question? Okay, I'm gonna be quiet. You guys have the homework, and it should be in the homework packet.